Let us try to understand hierarchical clustering using universities dataset. So we have an Excel sheet called universities_clustering.xlsx. We are going to load this. Since this is XLSX, we are going to load this dataset into R using the function read.xlsx. Right, so let me go to desktop, datasets underscore va2, we have universities underscore clustering. Let me open the dataset and first show you the dataset. Here is the dataset. So we have the universities, we have, I believe, 25 universities, which is in column A. Which state is that specific university in? That information is available in column B. We have the SAT score. You need to write a competitive exam to get admitted to any of the B schools, that is this. And we have top 10, if I hold my mouse, percentage new freshmen in top 10 percentage of high school class. So how many people, how many students were there in, or what percentage of students were there in top 10 during their high school? That also determines, on how good a B school is or not. Acceptance ratio. If 100 people are applying for a university, how many people are getting admitted? That is what this column E is. And you have column F, which speaks about student faculty ratio. That means this 13 here means for every 13 students, you have a professor. And then you have the expense here. Expense is given in dollars, and we have the graduation rate in percentage. So this is the data set. Our objective here is to group the related universities together so that it gives a lot of benefit to two stakeholders primarily. One is students, another is dean of the college. So that is what we are interested in here. So let us now try to look into the R code and try to solve this problem. And this is XLSX file, and we have one sheet here, first sheet, that is universities, first sheet. Normally Excel sheets can have multiple sheets also. And here is the code. So let me run this function. As you all know, control enter or command enter would do that. I got this error that we could not find function read.xlsx because maybe I have not installed it, or maybe I've installed the package and I've not loaded that. If you were to install a package called XLSX, the function is install.packages of XLSX. But if you want to check on whether you have installed it beforehand and whether you have loaded that or not, you need to just go to packages here, search for XLSX. There we go. We have this package called XLSX. So let me put a check mark there. Right? So the moment I've put a check mark here, it has triggered the function library, and also it has put a check mark against XLSX jar. So this is a dependency package, right? So when you loaded XLSX here, RJava and XLSX jars got loaded because these are your dependency packages. If you see here, RJava, you also have a tick mark there. So these are your dependency packages. Fine. Or you can alternatively run this function library of XLSX. Yeah, if you load that, by default the dependency packages also would be loaded. All right. Now let me run this function. Oh, my bad. I've run two at one go. That's okay. Let me clear that and run it. I want to explain one by one. So here we have used this function called read.xlsx, and within this brackets, within double quotes, we have provided the path location of the dataset, and here we are saying that read first sheet. Excel can have multiple sheets. You're saying that please read the first sheet. And using this assignment operator, we are assigning it to an object called input. That is all that we have done here. Now, when I look into the input dataset here, you just need to click on that and view of the dataset name function gets triggered. Now if you look at this, accidentally another column got added which doesn't really make sense. The ninth column here, which has all an A. And if I try to scroll it down, you have row number 26 and row number 27, which are completely irrelevant. Yeah, which are completely irrelevant. And what we are trying to do here is, on this input data set, all right, let me explain it in this way. So whenever you have the brackets, which are square brackets, it always has rows and then columns. We are here trying to refer to rows 1 to 25, and then we are trying to combine first column, and we are getting rid of the second column here, and we're considering only column 3 to 8, right? First column, and then we are trying to consider column 3 to 8. That is what we are trying to refer. And we have this 1 to 25 rows. So if you run that function, another data set called my data gets created. Now if I click on that, yes, this is what we wanted. We wanted 1 to 25 rows, and we did not want 1 to 27 rows. Step 1. Step 2. We wanted column 1 and columns from third to 8th column, right? So if I go here, we are referring to column 1 and 3, 4, 5, 6, 7, 8 until graduation rate. We have taken that and we have copied it here. Now I'll close input. That is irrelevant. We'll be working on my data, which has all the relevant rows and columns. If you look at this data, I feel that all the variables are of different scale. Dollars or expenses is of a different scale altogether. SAT score is of a different scale. Graduation rate is of a different scale, and student faculty ratio is of a different scale. And everything has different unit, right? So the units and scale, they are very different. These two are extremely different. Hence, we are going to normalize the data using the scale function. Scale is going to apply this formula. This function is equivalent to z is equal to x minus mu upon sigma. This is exactly what scale would do. All right, so let me run that. And we're trying to run it on my data. This is my data. And whenever you have square brackets, I've already told you that it's rows comma columns. If you have a blank space, for example here for rows you have a blank space, meaning you want to refer to all the rows. And when it comes to columns, you want to refer to columns 2 until 7. Yeah, you want to refer to columns 2 until 7. Column 2, 3, 4, 5, 6, 7. And I'm assigning it to another object called normalized data. Why can't we normalize the first column here, universities? Because, formula is z is equal to x minus mu by sigma. How can you calculate the average of these? How can you calculate the standard deviation of this? We cannot, right? Hence we are refraining. All right. Now, I'm running distance function on the normalized data, and I'm trying to use Euclidean distance. I'm trying to use Euclidean, which is the default method of the normalized data, and I want to calculate the distance between each and every record, and I want to store it in D. So let me store it there. There we go. So we have D, which has all the distance values. So if you can call D and C, it has all the distance values, right? Which we have already done hands-on. Though we had only 5 data points, here we have 25 universities. That is the only difference. Yeah.